Okay, I appreciate the opportunity to address the symposium. I'd like to begin with my first slide. See if we can make sure it's in focus. Okay, I'd like to talk about issues of authenticity and image formation. What I'd like to talk about first is something that we've talked about a lot in this symposium, and that was the issue of the possible connection of the Shroud of Turin with the Mandylion. Back before our 1978 expedition, I took this picture of a cloth model of the Shroud that I had. And if you look at this, which I had folded to, according to Ian Wilson's theory or hypothesis of the image of the Mandylion, you can see that there are a number of fold marks that are present on my cloth model. And I thought that it would be very difficult to believe that if the Shroud was indeed folded as the Mandylion for almost 1,000 years, that there shouldn't be some artifact of that folding still present on the Shroud, namely in terms of its folding pattern. So I studied this problem based upon the 1978 stirrup photographs, and some other photographs, and I would like to show you some results that I have in that area. First of all, let's ask what we're looking for. If the Shroud is folded as the Mandylion, we're looking at a way for the Shroud to be folded eighth-wise, so we ought to see fold marks. These are very special fold marks that ought to run the entire width of the Shroud. They should be uninterrupted, thereby not showing a folding longitudinal-wise, lengthwise, and these fold marks ought to be in an eight-fold pattern running across the entire length of the Shroud. Now, I don't know how well you're going to be able to see all this, but I'll do my best to illustrate these with the slides that I have. What you're looking at is the dorsal image, and this is the midpoint of the Shroud. That is the axis of symmetry. Now, what we would be looking for would be a fold mark that would be 1/8 of the way along the length of the Shroud. In fact, at this location right here, we in fact find such a fold mark that runs completely across the entire width of the cloth. If we go the same distance, the same 8-fold distance, we find another one. Now bear in mind, this is on the Henri 1931 photographs. And indeed, if you go even further, 1/8 of the way again, we can find, as the arrows point, another fold line that runs the entire width of the Shroud. Thus, just on the basis of these that you see in the dorsal image, it would appear that the Shroud has indeed been folded in an 8-wise pattern sometime in its history. Let's go to the frontal image, again using the 1931 Henri photographs. Difficult to see, but here's the midpoint of the axis of symmetry on the Shroud. We come down just below the face image, and there is a fold line that runs right where the arrows are, right at this level here. These fold lines are not exactly horizontal, but they kind of tilt at a slight angle. And a very visible one in the 1931 photographs, again 1/8 of the way further from this fold line, is another one that you see here. Those are the only set that I see on the 1931 photographs from Henri. I've adopted a nomenclature where I start at the dorsal end of the cloth. I call that O for origin, and in each eighth-wise location I designate as the letter A, B, C, D, E, and F. So at the midpoint, which would be a folding direction, that's the location D. This one would be the location E. This one is the location F. And if there's one here which we do not see on this photograph, it would be called location G. And then this would be the end, which I call Z. So if you keep that nomenclature in mind, it'll be helpful. 1978, we took waking light photographs of the Shroud. This is for comparison. This is the Shroud image. These photographs were taken with lighting coming in at a grazing angle. This was more of a last-minute experiment, but it shows the tremendous numbers of wrinkles and creases all over the Shroud of Turin. But in addition, if there are fold lines here, such as we see in the 1931 photographs, they ought to be visible on these raking light photographs. Let me show you what you can see from the 1978 raking light photographs. Difficult to see in this lighting, but these are here. I've shown where arrows indicate fold lines that go across the entire width of the shroud. The surprising result is that in the location here, which I call the F location, we find four horizontal fold lines that run across the length of the shroud. They're equally spaced, and they're the only location where you see something like that. Otherwise, the fold lines that we see in 1978 are here. That's A. There's B. This is C here, tilted a little bit. This is the midpoint of the shroud. We do not see, or at least it's not that obvious, the one going across here, but we do see it in 1931, 4 of them here, and we do see at this location, you may even be able to see that running across here. That's the location G fold line. This is the location C fold mark that runs across the dorsal image. You can see it right across this way. This one runs the entire width of the shroud at that location. This is the location, this says K, but it really should be E. Something happened in my computer. But I think you can see, even in this lighting, the fold line running across the width of the shroud, right underneath the facial image. At the location D, in the transmitted light imagery that we took, the Stirrup took in 1978, you find a stress line, probably a fold mark, probably some, I would guess, separation of the weft threads due to probably stresses due to folding. In the raking light photographs, let's look at it a little bit closer, particularly in this region. These are the 4 fold lines that run across the width of the shroud. You can see them better. This is what I call the fold mark G. It is in the proper location to be an 8th-wise folding pattern for this Turin shroud. Let's look at the location F fold marks in more detail. This is a computer picture that I made of that. You can see 4 fold lines running across here. I designate them F1, F2, F3, F4 to designate the F location. Now, if we look at another raking light, just a normal photograph in 1978, I think this is interesting because here you can see the 4 fold lines running across here. They're at the level just below the hands. This is part of the location A fold line on one side of the shroud. This is it on the other side of the shroud. And you can trace this all the way across on a good photograph. Location B, unfortunately, is not very clear. This is part of it here, but it runs completely across the width of the shroud. You can also trace it. It's very visible. So I believe that there are indeed fold marks running across the entire width of the shroud, which are shown at these locations on the dorsal image and at these locations on the frontal image, on the Turin shroud. I've put the locations at the midpoint. I've had these line up, and you can see that the location C and the location E fold lines on the frontal images are virtually the same. They're even tilted, but both of them seem to be tilted at a slight angle relative to the horizontal. At location E on the dorsal, we have a companion set, although these are 4 fold lines appearing at location F. Location G and location A and location G are virtually at the same locations. So we have a folding pattern that seems to be consistent with what one might expect of if the shroud was once folded as the Mandylion cloth. Now let's ask, how old are these fold marks? Can we say anything about that? Okay, first of all, let's go through a little bit of history. This is a 1988 photograph taken at the time of the radiocarbon sampling. You can see very faintly, but you can see them, the 4 fold lines in location F. This is the 1978 photograph, 10 years earlier. Again, as I showed you before, here are your 4 fold lines at location F. Going to 1931, you don't see all of them, but you certainly see a very marked one here. I believe this is F2 in my nomenclature, running across the shroud. And in fact, when you go to the 1898 photograph of Secunda Pia, indeed, we see the F fold line there. So therefore, we can say that the folding pattern that we have must be at least 100 years old. But can we say anything more about that? Turns out that the location C fold line right here runs through the 1532 fire, which is a datable event, December 4th, 1532. Now we see something here. On this fold line, on this patch, seems to kind of propagate through it. The patches were sewn on in 1534. This patch here, however, does not show the fold line. Going to the other side, where the C fold mark goes through the cloth, we find no visible or appreciable deformation of the fold line going through the patchwork of 1534. But we have to be careful here. We could be fooled, because if you sew cloth on a cloth that already has a crease mark in it, it's possible that stress in time may propagate into the patch that you put over it. A better way to test the age of this fold mark would be, in fact, to look underneath the patch and look at how the fold mark propagates into the charred material. Fortunately, Stirrup took x-rays of the shroud in 1978. This is what the x-ray shows of the C fold mark. The fold mark propagates through and under the patch, and what you find is that the C fold mark, if I can keep my hand steady enough, here and here, propagates up to the edge, which is here, of the burned shroud. It goes right up to the edge, and it picks on one side and it picks up on the other. I believe this is clear and unmistakable evidence that this fold mark the C fold mark must have been in place on the shroud prior to 1532. And therefore the entire pattern must have occurred prior to 1532. We might be able to do even better, because as it happens, I'll keep my nomenclature straight, the B fold mark, which is this one, runs right through another fire event, which is this, and just goes right through some of these. To my eye, it looks like it goes right through it, as if those marks, those burn holes, are not there. This is something that needs to be looked at further. I am not going to say that is for sure. I need to see better photographs, ideally to study the shroud directly to be certain. But if this is true, then the fold marks would predate this fire event, and we know this fire event predates 1532. We have pictures of the paintings with these burn holes prior to 1532, for example. If you want to push it even further and say that you take this to the Prey manuscript that was talked about earlier yesterday, which dates back to about 1120 or there, which seems to possibly show these holes in the cloth, then you can start saying that these fold marks actually predate that event. At that point, you're talking about a folding pattern that is very old on the shroud, and in addition, the shroud must have been folded in this configuration for a very long time for fold marks to exist for that period of time. But I'm certain that these fold marks do in fact date at least to 1532. As such, I think they are, and because of the pattern, it looks like they might be candidates for true Mandylion fold lines. But can we say anything more about it? can you fold the shroud up to give you a face-centered image? That'd be the next question you want to ask. Well, it turns out, fortunately in 1978, we took raking light photographs of the shroud. That is where you illuminate from one side. Here's a piece of cloth that I have that has been folded. I've illuminated from the bottom. Now when the fold mark goes up, and it folds upwards, this side is bright and the downlight side is dark. But when the fold line gets to a curvature where the cloth is folded upwards, you see just the reverse in lighting configuration. It's dark first and then light. So in other words, if you know what the direction, the lighting direction is, you can tell what the folding direction is. Also note that there is a lengthwise fold line in my cloth model, and that the curvature of the cloth actually changes across the fold line. This does not happen on the shroud in what I'm calling our candidate Mandylion fold lines. Now let's look at the shroud. In particular, let's look at the F folding pattern. We know that in this case the lighting direction was from the bottom, so hence we have information as to what the folding direction is on the shroud. On the first one, which I call F4, you see it's light first and then dark. Following that, in F3, you see just the reverse. You see a dark and then a light. It's preceded by a light. This one is folded downwards. This one is folded upwards. And hence you can go across the entire width of the shroud on these raking light photographs and get a handle upon what the folding directions are for the shroud. Ideally, you want to go and look at the shroud directly, but we do have some information available to us here. Let me show you my computer solution to attempting to fold the cloth up according to these fold marks. What I've done here is I've taken the distance between the various fold points that I measured on the shroud, and they look like this. So you got A to B, B to C, and so forth. Now, we have the F folding pattern, which I have constructed as a separate entity here. I also have included what I call D1 to D2. I forgot to mention this, but it's a band of discoloration that lies behind the head image. I'll have more to say about this later. I want to keep that separate because it turns out that the width of that band of discoloration is virtually identical to the width of those fold lines in the F folding pattern. So I want to at least have the ability in my computer analysis to deal with that if necessary. Well, anyway, the next step you want to do is you want to join A to A, C to C, D to D, or E to E, G to G, because that's where the folding directions are. So I'll go ahead and do that with my computer. So I've gone from this stage to this stage. Now the next step is you want to assemble all of these pieces, just like a puzzle, in such a way that they don't overlap one another or run into each other. And I'd like to see if it's possible to do this and have the face centered. So let's go. Let's see what we do with this. First of all, I take the part that has the shroud face. The shroud face is on the outside edge here. Okay, so this is the DE fold direction. To that, at the F point, I patch the F complex corresponding to the 4 folding directions. Then I have to assemble the rest of these. Well, the next thing I do is I take one and I assemble here. Then I've got these to assemble. I go ahead and assemble the rest of them. Now notice what happens. This D1 to D2 lines up right above where the F folding complex occurs. So here's an initial guess of what you might be dealing with. But when you check the folding directions, I find that those two here in this first attempt are wrong relative to what you see on the shroud. They need to be inverted. Fortunately, it's easy to invert those. So when I do that inversion, the solution looks like this. But now we find a problem in that this part of the cloth seems to be high compared to this. Well, remember how I measured the fold lines, and also remember that some of those fold line directions were tilted at an angle. Perhaps that going down the center line is not the best place to make those measurements. Perhaps a better place to make the distance measurements between fold marks is to go along the edge of the shroud. So if I do that, I can change very slightly the lengths between fold marks, going from blue to red for each of the fold patterns, then reassemble everything exactly as I did before, and then what you get is something that comes together rather nicely. In addition, it's very tempting to put something in between where the F fold marks are, something like this, which would be a structure that I would put in there with my own mind, but it seems very tempting to do so to account for why those fold marks ought to be there in the first place. But what's interesting at this point is that you can see that it would be easy to get a definition of this doubled in four cloth, as is the name of this cloth in Greek. Let's go further. Now, to get the high curvatures of the fold marks, you have to compress the cloth. So let's compress it with a structure on both sides. Of course, if you're talking about a Mandylion possibility, you want to leave a hole here. Put a top and a bottom. Put everything together, and you get a complex that looks like this. Now, when you then take the computer solution and translate it to something real, I have a cloth model of the shroud. My wife Rebecca and I actually did this folding pattern. Here's the little block at the top with each of the four corners in my reconstruction corresponds to the F fold marks, and then you have a frame that comes down like so. When you put everything into a box, it folds up nice and neatly, and the thing looks like this. Now, let's note that on the artist copies, which I've taken from Ian Wilson's one of his books, there are a number of copies of the Mandylion, particularly this one, this one, this one, and this one, look very suspiciously like what we just constructed from the fold marks on the shroud. And these are supposed to be copies of the Mandylion with the face centered. And I believe that from this analysis, it looks indeed like you can actually fold up the shroud according to fold marks that are visible on the cloth to get you to something that looks like this. Well, I'd also like to point out that there are fringe elements upon this cloth, but I think what that is, it's attached to an overlying cloth, not the shroud itself. So there's no inconsistency by having fringe on the not present on the shroud at all. In fact, I don't think it should be there. We know of no folding pattern that looks like these fold marks since the shroud has been in Europe. In fact, in Mireille, the shroud was exposed openly like this. It was not exposed as a face image. Now, the last thing I'd like to show in this particular part of my talk is this particular icon. This is found at the St. Catherine's Monastery in Egypt, in the Sinai. My wife Rebecca and I made a trip there to Sinai to look at this icon. It's very interesting because look what you've got. You've got a cloth that's folded. It looks like it almost has a 2-to-1 ratio in its length or width to height. Look at the size of it. 1/8 of the shroud is about the length of one's finger to one's elbow. And in the scale that you see by the two angels, that length is about the width that you see there. The scaling looks very reasonable. What you've got is this cloth, which is they're not just holding the cloth from the top. The cloth looks like it's on some kind of a structure because look at the hands. The hands are holding the cloth from the side, not from the top. Looks like it's balanced here. The cloth itself is on a cushion. This is a throne. This is a footrest in the Orthodox tradition of icons. Also in front of this cloth, you have the Orthodox cross. You also have two angels and an old man and a young man. I think that this old man and young man are St. Peter and St. John. The two angels are John's two angels that were in the tomb. So what you have, I think, is a iconographic suggestion that this cloth is associated with the burial cloth, with a burial, because you see Peter and John and the two angels And it looks like it's, at the same time, folded up. We don't see a face, however, on this, at least I don't. But it's folded in a manner similar to the way that I've arrived at through the folding analysis of the Turin Shroud. Now, I'd like to now switch gears. I'll have to go through this fast. But now I'd like to talk about the issues relating to image formation, another topic that I've been very interested in, which I hope you'll find interesting too. We've talked a lot about image formation. I think it's important that we stand back and look and think about the shroud and think of the various characteristics that we have to explain with respect to this remarkable image. Let's review this. You'll see a few things that I think you'll find probably new to you. Okay, first of all, we have the normal positive negative characteristic of the image. We see a variation of lights and darks on the shroud. We see the lights and darks because, in such detail, because each point on the shroud is mapped one-to-one to some point on the body of the man of the shroud. Okay, so that means that you've got a point-to-point mapping that you have to deal with. But if you convert, and most of you know this, if you convert the image intensities to proportional degrees of relief, you find a three-dimensional representation that looks like a three-dimensionally reasonable human body. Look at the face, look at the pectorals of the chest, crossed arms and legs. You've got a situation here that I think tells us that there is a correlation between image intensity and cloth body distance. So that's in other words, that the image formation mechanism somehow acted through space. But we've got a problem. The first slide showed a high-resolution image. The second one showed a three-dimensional image. It's very difficult using conventional mechanisms, and I've spent many years trying to do this, to get those to work. The problem is that points on the, say, the lips, if you're talking about radiation or diffusion, will tend to blur their information onto the cloth, and you'll wind up with a blurred image. But that's not what you see on the Turin Shroud. An experiment can show this very easily. Here's a face, a statue of the man, of just a bearded man. And from this I have created a diffusion image by diffusing temperature through a paraffin model of the space between that face and an overlying cloth. Such an image looks like this. You get a blurred image when you try to deal with these kinds of mechanisms. You'll also get this if it's just simple radiation coming off the body. Direct contact images won't give you the three-dimensional image. Now here's something that I think is rather interesting. This is an ultraviolet photograph of the head of the shroud taken by Stirrup in 1978. This image has been computer enhanced. I did it myself. Now what you find here is you see the three blood, but look above it. You've got a continuation of that three blood going into the forehead. Now what's interesting about this is that this material here is blood-derived pigments. This looks like the same thing that you find in the body image. In other words, that looks like degraded cellulose. In other words, it looks like the blood is transitioned from being able to transfer blood information, blood material to the cloth, to recording an image of itself, just like the body did, onto the cloth. I interpret this as that the original blood flow looked like what you see here, but where the cloth had just happened to touch the blood mark, blood was transferred, but where it did not touch, an image of that blood clot was transferred to the shroud in the form of cellulose degradation that we have talked about before that seems to be characteristic of the body image. This would also argue, again, that the image formation mechanism seemed to be relatively insensitive to type of surface that the image was generated from, and are also acted through space, because otherwise you would have blood transfers at this point here, because you did here, and this is all part of the same clot. The body image on the back side, compare these two. The frontal image looks like a nice continuous image, continuous shading. But you go to the dorsal image, it seems to be rather splotchy, like a mosaic pattern. It does not seem to be continuous. In this area, you see blood marks due to the scourging. You see blood marks due to the scourging up here, but in this location you see body image. Here you do not. But yet the cloth must have been very close, but there's no or very little body image that's been transferred into this location. I think the frontal image is the so-called three-dimensional image, but I think the back image, therefore, is a direct contact image, not like the frontal image. That difference has to be explained, I believe. In fact, the dorsal patterns that you just saw correlate with where a body would rest firmly upon a hard surface. Earlier this morning, Dr. Lavoie talked about a blood mark right off the elbow, and he argued that this blood flow would argue that the cloth was in contact with the body to receive that clot. I believe that Dr. Lavoie is correct in that analysis, but the interesting thing is that in this location, we don't see any body image, although we see body image up here. But yet the cloth must be in intimate contact with the body. Here it is. This is the body image, but right in here, that's the blood clot. You don't see any body image there. What's going on? Why does the image formation mechanism only care about the top of the body and not going off into the sides? The color of the frontal image on the body image, it looks like a brownish color, very similar to the 1532 fire scorch marks. Not surprising, Dr. Adler told us yesterday that the chemistry of this is degraded cellulose, and he spent a lot of time establishing that point. You can see that in the color of the body image in the 1532 fire marks that chemical conclusion makes sense. There's also another situation here that notice that you see the body image in reflected light, but here you see the scorch marks of the 1532 fire. They're both about the same intensity. But when you go to transmitted light, you see the scorch marks of the 1532 fire, but you don't see the body image, or at least it's very, very much subdued. This is a good demonstration that the body image of the Turin shroud resides on the surface fibrils of the threads which make up the shroud. Ultraviolet fluorescence photography. Here's your blood mark. Right around the blood mark, unfortunately I can't hold my hand steady at this distance, but right here, you see a halo extending into the body image surrounding the blood mark. And what's going on here, we think, is that is the serum from the blood that exuded into the cloth when the cloth was put over the blood mark, and that the body image was blocked, was prevented from being formed onto the shroud by the presence of that tenuous layer of serum. Now let's go to the photomicrography. This is a background cloth of the shroud. There's no image, no nothing here. Notice how white it is. The next picture I'm going to show you is at the tip of the nose. The tip of the nose is browner. I want you to watch what gives you that color difference. What gives you that color difference is the body image that we're trying to explain. Okay. See how much browner it is? Let's go back. Here's the white control. There's the tip of the nose. Now what's interesting here is that the thing that's giving you this brown color are individual fibrils that are colored. But notice that these individual fibrils, again I'm going to have trouble holding my hand steady, but the brown, there's a fiber right here and it sits right next to white fibrils over here. And there's some more brown fibrils. Here's a white band, some brown fibrils here, and so forth. There's been a selection process that's been involved in making this body image, which we need to explain. But it looks to me, and I wish we had some three-dimensional stereo photographs at the microscopic level here to see this, but it looks to me like it's the high points of these fibrils, of these threads, are what have received the image. When you get up to this area here, which is the sort of this fuzz, notice what happens. It's lifted away from the cloth, but every one of these fibrils that are lifted away in the fuzz are colored. So as soon as you pull away from the cloth, this caught the entire discoloration mechanism, whereas this didn't. As a first cut at this, I would, as a physicist, I would be tempted to argue, to think of this as being a radiation effect, because of possibly shadowing when you get down on the surface of the threads, whereas these fibers up here are not shadowed. Let's go to another way of looking at the shroud. This is the frontal image in normal reflected light. At the Jet Propulsion Laboratory, we did a color exaggeration of the shroud. Looks like this. Notice that around the fire marks of 1532, you see greenish halos. The interesting thing is that you see greenish halos, let me hold my hand steady again, around the outside of the body image. It's unmistakable, it extends away from the body image. There's been some cellulose modification going on beyond what we normally think is the sensible body image. Look at another one. Whoops. What? I don't think my slide projector likes that slide for some reason. Okay. Right around here, there's a greenish image. It goes to the background, and then you go to the greenish part of the fire. This clearly is associated with the body image. It's extending away from the body image. The human eye can see color better than it can see shadowing. Again, look at the dorsal image. There's a halo. That must correspond to cellulose degradation of a very light nature. To me, that suggests radiation, as a physicist again. Radiation would do something like that. So I have looked at radiation. I've taken cloth, I've put little holes, and then I've exposed my linen cloth to ultraviolet radiation. And what you wind up with are the two little holes here and here. And if you can see, they seem to be slightly bleached. I chose ultraviolet radiation because it's a neutral radiation. It is charge neutral. You don't have to worry about charge effects when you start moving charge around. Also, ultraviolet will interact only with surface fibrils of threads. And it does photochemistry. We can see that it does photochemistry because if you take a long wavelength ultraviolet, you can see that those little areas will start to fluoresce. And as the previous speaker mentioned, when I artificially age these samples, the part that's been hit by ultraviolet will age faster than the background cloth, and you actually get a color reversal, and the image starts to come out with you in time. Now, there might be some evidence of this on the shroud. Look at this area here in the ultraviolet fluorescence photograph. This is a band structure that you see at the back part of the head. Now, this is the band, the D1, D2 that I showed you that occurs at the top of the shroud when I do my Mandylion folding that I showed you before. There is a definite discoloration. Let's look at this on my computer. This is an ultraviolet fluorescence photograph that I scanned. Here is the line of demarcation. Here's another one here. That's my D1 and D2. The width of this is equal to the width of those two fold marks, these F fold marks that I showed you before. Now, notice that you don't see, or you hardly see, the body image. The body image itself has a discontinuity as well as the background cloth. And what I did is I singled out this area with my computer and I image enhanced it. In other words, what I did is I lowered the intensity and I did a blue shift. When I did that, I was able to make the background go away. But look what happens. The body image doesn't come back when you do that on the computer. It's very possible that what we're looking at here is a retarded area where the cloth has not aged for some reason. A logical reason might be that that's at the very top of the frame, which I suggested would be the Mandylion, and that aging has been slowed down, and so has the body image. And so I think this might be evidence that the body image is in fact aging with time and changing with time. Now I'd like to show you something I think you'll find very interesting. These are the hands of the man of the shroud. It has been noted by many scholars, writers, that the hands of the man of the shroud appear long. Let's just see how long they really look. This is a computer image And in this particular image that you see here, you can see the fingers looking like they're going all the way up to the wrist. This area right here is where the blood mark is in the wrist. And I think you can follow these. I can even see it here. It goes all the way up to the wrist. It looks like, and this was a suggestion made by Dr. Giles Carter, is that he thinks you're looking at the finger bones of the hands getting imaged onto the shroud. I think another thing that's interesting is right here. Look at this bottom hand. I think you can see the bottom hand extending and getting imaged right through the top hand onto the man of the shroud. If you just follow it right along, it goes right at the same level. Right there. Now, to help us see some of these things a little bit better, let's go to the next slide. You can't see it, but I selectively took this area and then I darkened it. So I can make this finger part equal to this finger part in intensity. When you do that, then you really start to see the effect of the elongation, how long these fingers really are by using a computer-aided technique. You see, this is the area that I enhanced. So you can see the fingers, they're very long, they're way too long, and I, in fact, do think you're looking at finger bones. A possible suggestion would be that maybe in crucifixion, the hands would dehydrate. Well, the most dehydrated hand I could think of is a mummy. And if you look at the hands, yeah, you see the fingers are thin, but they don't extend all the way to the wrists. So I think you're looking at something that's like the finger bones getting imaged through the tissues of the hand right onto the shroud. Now, something even more surprising is this. Take a look at the top hand, and I'd like you to note that on the top hand we see a discoloration right here. On normal images of the shroud, this has the same color. This little blotch right here has the same color as the rest of the hand, as the rest of the body image. Now, with my own hand, and you can see my fingers just like you see on the shroud, and you also see kind of a splotch here in the same location as we see here on the shroud. What is that? Well, if we sharpen up the x-ray, I intentionally blurred this, we find that that's my thumb curled up into the palm of my hand, and it shows up on the shroud. So what I think you're looking at here, and it works very nicely, you can do this on a full-scale model in the back, I think that's the image of the thumb of the man of the shroud getting imaged through the hand, just like the finger bones of the hand go onto the shroud itself. Notice that the man of the shroud does not have any thumbs visible. You see the fingers, but you don't see a thumb. And we also know from the work of Barbet that if you put a nail in this position, that nail damages the median nerve and drives the thumb into the palm of the hands. Well, it's in the right location, it's the right size, and it shows up on the x-ray. I think that's what we're looking at. One possibility we need to check, however, is could it be an interplay of discolorations of some kind? This is a transmitted light photograph. You've got bands of discoloration here. This is the thumb area. There's no correlation whatsoever. Therefore, it's not a random splotch. I think this is a true part of the body image. Let me just go to the last tray, and I've only got about 10 slides, and that's it. Whoops. Okay, we'll get set up here in just a second. I think we have to recycle something here. What I'm trying to say here is that we have a lot of image characteristics. Some of them are rather surprising, I think. I believe the Turin Shroud is an image that has a lot of extraordinary characteristics associated with it, and we have to come up with an explanation for this. The shroud exists. I've seen it back in 1978, had the honor of being able to see it and study it. It does exist, and it exists with these characteristics. These are things that which we have to explain in any successful theory of image formation. How are we doing? Okay. Now, this morning you've heard Dr. Lavoie talk about the blood in the hair. The blood appears to be in the hair. However, what he showed, if I can borrow one of his slides, he showed that hair actually winds up on the sides of the face, not in the hair. In other words, it looks like the blood, as he argues, from the sides of the face are somehow transposed away from the sides of the face into the hair. In other words, and he even said this, it's as if the cloth has been straightened somehow from the time that the blood images were transferred to the cloth to when the body image was transferred to the cloth. Now, there's another characteristic that I've worked on, and that is, if you have points on the body image, where do these points on the body image wind up? Are points on the body image, for example, imaged perpendicular to the body surface, or perpendicular to the cloth surface, or possibly vertical? Well, here's a simple demonstration that if you take a intensity trace across the shroud image, you take a face and a cloth over it, do all this to the proper scale, you can show that the body image best seems to be vertically aligned under a draping cloth. And I've taken this one step further by actually trying to compute body images based upon this, and I'm convinced that the mapping is a vertical direction. To me, what this suggests is that gravity somehow must be involved in this image formation mechanism, because it tells the locations on the body which way is up, and apparently the image formation mechanism knew this. Now, one other thing I want to do before I finish and make my concluding remarks is in this area right here. This has been thought of by many people as a side strip because there's a blanking area here. I don't think that's what this is. You can correlate this with the change in the herringbone pattern at that location. I do not believe that's what that is. However, what we can do with the computer is we can lighten this area up relative to this and bring these features to the same level. And when you do that, here's what you wind up with. Something that looks like this. It looks like the eye socket is kind of pulled away from the face back into the hair area. These are my statues which I computed. This is computed from the image intensity structure on the shroud from a draping cloth using a vertically aligned, assuming vertical projection. This one assumes perpendicular to the cloth. This body image is much, much too narrow and thin. It does not work. This is, I think, solid evidence that there's a vertical alignment all over the frontal image with respect to the shroud. Okay, so now how can we explain the image? I've tried for many years to try to explain the shroud image in what I would call natural physics, chemistry terms. I've spent many years doing this, and I just cannot get these things to work to satisfy all the characteristics of the image that we see. When I first started this 20 years ago, almost 20 years ago, I was very happy with Vignon's vapor graph hypothesis, but it doesn't work because it blurs images. But I think, but there is a way that I've conceived of. It's if you're willing to take an excursion into something a little bit extraordinary, radical here. This idea, at least qualitatively, I think can explain all the characteristics that I just showed you on the shroud. You're looking at a cross-section of a face in sketch. Here's a cloth draping over the body. Where the cloth touches the cheeks, if there was, say, blood there, as Dr. Lavoie would argue, would come right down the sides of the face, blood could be transferred to the cloth. But here's my idea. What if you postulate that for some reason, and I don't have any idea what the reason would be, that this cloth fell, actually collapsed vertically through and into the body region. And as it did so, in other words, it's like the cloth and the body almost for some moment of time occupied the same space. And as they did so, they interacted with each other in such a way that an image was recorded onto the shroud by radiation. Maybe ultraviolet, maybe something else. I don't say for sure. But what would happen is the blood on the cheeks would actually wind up in the hair, just like what Dr. Lavoie was saying. You also have other explanations. Parts of the cloth that were originally further away from the body would have less intensity than parts of the cloth that were close, and this is an explanation for the three-dimensional image. It's also an explanation for the high resolution because it's a point-to-point mapping, don't you see, on the cloth from the body. You also have no side images on the shroud, and these side images pull away from the sides. The dorsal image is a direct contact image because it doesn't have any muscle movement. In short, I think this explains the image on the shroud, at least qualitatively. You're looking at this back in Colorado. I'm finishing. If you want to have a picture in your mind of what I'm thinking about, it looks like this. Cloth around the body, something funny happens to the body, something strange with radiation, the cloth falls through it to this condition. That event, I think, can cause an image like you see on the Turin shroud. The last slide. Thank you for your attention. I know it's hot in here, and thank you for your patience with allowing me to get through all this information here. This is where we're located if anybody has any need for correspondence. Thank you very much.